Up next, we'll dive deeper into some basic building blocks of Python syntax. Things like variables, expressions, functions, and conditional blocks. At first glance, these pieces may seem pretty simple, but when we start to combine them, they become a lot more powerful. Understanding a programming language's syntax isn't too different from learning a spoken language. For example, the best way to learn Spanish is to visit a Spanish-speaking country. Immerse yourself in the culture, listen to the people, then figure out how to arrange the words to form a sentence that another speaker can understand. The same is true for programming. When you immerse yourself in Python programming, you'll learn how to formulate statements of code that the computer can understand. This is called syntax. Okay, so as you go through the next few videos, keep in mind that our main goal is to learn the language's syntax. So we'll focus on how to tell our computer what to do, not on how to get it to do complicated tasks. Like before, we'll run through some simple exercises to help you see the concepts in action. And as you pick up the new skills and get to grips with different tools, we'll start to write more advanced scripts that tackle more challenging problems. Again, if at any point you feel confused or that something just isn't clear, remember, you can watch the videos and take the practice quizzes as many times as you need. The key to getting good at programming is practice. Practice and practice. You have to keep working your programming muscles in order to get strong, just like building muscles in the gym. Train hard, train regularly, and you'll be tackling more weighty coding problems in no time. All right, ready to jump back in? In the next video, we're going to learn all about data types. Let's get started. In earlier videos, we called out that text written between quotes in Python is called a string. In programming terminology, a string is known as a data type. Whether it's a mobile game or a script used to automatically create user accounts, most programs need to manipulate some kind of data. And that data can come in a lot of different forms, or, like we call them, data types. A string is only one kind of data type found in Python. There's a bunch of others, like an integer, which represents whole numbers without a fraction, like 1, and float, which represents real numbers, or in other words, a number with a fractional part, like 2.5. Generally, your computer doesn't know how to mix different data types. For example, adding two integers together makes perfect sense to computers, like this. Adding together two strings also makes sense. We just end up with a longer string that contains the two, like so. But your computer doesn't know how to add an integer and a string. If you tell it to mix these two different data types, your computer isn't going to know what to do and will raise an error. Check it out. Oh no, our first error! But don't panic. Errors are a common part of programming, and you'll probably have to deal with them a lot. The trick is to think of errors as little clues from your computer to help you improve your programming skills. Read the errors carefully, understand what they're telling you, and then use that new knowledge to help you fix the mistake. In this example, the last line of the error message shows us that we've encountered something called a type error. When we get a bit of explanatory text that tells us that the plus sign can't be used between an int type and an str type, which are short names for integer and string, thinking about what we've already learned about strings, integers, and mixing data types, can you guess what the error is trying to tell us? The message unsupported operand type tells us that we can't add the integer 7 and the string 8 because they're different data types. But what if you didn't have an instructor to helpfully point that out? How would you know? You'd need to use your research skills and the resources we called out earlier in the course to do some investigating. For example, you could look for information about the error by pasting the type error message into the search bar of your favorite search engine. This is a common trick used by almost everyone learning to code, and even by experienced developers. You'll usually find that other people on the internet have reported similar errors and solved them too. Back to our example. Maybe you're thinking, aren't we adding two numbers here? Looks a bit like it, right? Well, look carefully and remember that anything wrapped in quotation marks is considered a string in Python. So 8 is a string here, while 7 is an integer. To the computer, adding 7 plus 8 is just as strange as adding 7 plus a is to us. And 7 plus a equals no sense at all. It might be helpful to think about data types in terms of information they can represent. For example, The name of a file would be represented as a string data type, while the size of that file might be an integer data type. If you're ever not 100% sure what data type a certain value is, Python gives you a handy way to find out. You can use the type function to have the computer tell you the type. This might come in handy when dealing with code that someone else wrote and you're not sure what data type it's using. For example, pretty neat, right? This tells us that A belongs to str class, which, like we said earlier, is short for string. The number 2 belongs to the int class, which is short for integer, and 2.5 belongs to the float class. We'll talk more about what we mean by class later in the course. For now, you can just use it as a synonym for data type. So now you know 3 very common data types in Python. There are plenty of others you'll be using soon, but don't worry about them at the moment. As we continue through the course, we'll come across more data types and learn how to interact with each of them. For now, just remember, mixing your data types will get your computer, well, all mixed up. So keep your strings with your strings, your integers with your integers, and your floats with your floats, and you shouldn't get in too much of a tangle. When we ask a computer to perform an operation for us, we usually need to store values and give them names so that we can refer to them later. This is where variables come in handy. Variables are names that we give to certain values in our programs. Those values can be of any data type, numbers, strings, or even the result of operations. We already used variables in some of our initial examples, like using them to store a name or a value. Now we're going to learn exactly how they work and how to make the most of them. Think of variables as containers for data. When you create a variable in your code, your computer reserves a chunk of its own memory to store that value. This lets the computer access the variable later to read or modify the value. Let's see this in action. Imagine a simple script that calculates the area of a rectangle using the formula area equals length times width. Area, length, and width can all be represented by variables, like this. In this script, we're creating 3 variables and storing different values in each. The process of storing a value inside a variable is called assignment. Here, we assign the length variable the value of 10. We assign the width variable the value of 2, and we assign the area variable with the result of the expression length times width. An expression is a combination of numbers, symbols, or other variables that produce a result when evaluated. In this example, we're multiplying the value of 2 variables to arrive at the value that we want. Finally, we use our old friend the print function to display the value of the area on the screen. All right, we've just seen how to assign values to variables, use expressions to calculate more complex values, and then print the contents of a variable. Variables are important in programming because they let you perform operations on data that may change. For example, if we extended our rectangle script to accept any input as the value of the length and width variables, we could calculate the area of a rectangle of any size. Or to give a more IT-focused example, say we have a script that performs a specific operation on a file. We could extend that script to perform the same operation on any file, but only if the program used a variable to store the file name. You might have noticed that we assign a value to a variable by using the equals sign, in the form of variable equals value. Generally, you can name variables whatever you like, but there are some restrictions. First, you shouldn't use as variable names any of the keywords or functions that Python reserves for its own, like print. Using these reserved terms will make your program confusing to read and will result in errors. Python also has some restrictions on the characters you can use to define a variable. Variable names can't have any spaces, and they must start with either a letter or an underscore. Also, they can only be made up of letters, numbers, and underscores. Let's check out some examples of valid and invalid variable names to understand this better. I underscore am underscore a underscore variable is a valid variable name. I underscore am underscore a underscore variable 2 is also a valid variable name. 1 underscore is underscore a underscore number is invalid because variable names must start with a letter or underscore. Apples underscore and underscore oranges is invalid because it uses the special character ampersand. Last thing, remember that precision is important when programming. Python variables are case sensitive, so capitalization matters. Lowercase name, uppercase name, and all caps name are all valid and different variable names. And that rule on variables is invariable. In an earlier video, we saw how we can't use the plus operator between an integer and a string because they're different data types. But what happens when we try to operate with an integer and a float instead? Let's find out. Woohoo! Error-free! Python has no problem performing this operation. But what's up with that? Aren't integer and a float two different data types? They sure are, but there's a lot happening under the hood here. Behind the scenes, the computer is busy automatically converting our integer 7 into a float 7. This lets Python then add together the values to return a result that is also a float. We call this process implicit conversion. The interpreter automatically converts one data type into another. We've called this out before, but it's worth highlighting again that Python operations aren't just restricted to numbers. You can also use the plus operator to add together strings. This lets you do things like create sentences from individual words. Just don't forget to add spaces to each word, otherwise the computer will run them all together. So, what if you really want to combine a string and a number? Is it possible? It sure is, but only with an explicit conversion. In Python, to convert between one data type and another, we call a function with the name of the type we're converting to. Let's see how this works. Now things are getting a little bit more complex. Let's take a moment to unpack this to make sure it all makes sense. In this script, we're first calculating the area of a triangle, and when printing it, we're adding it to a string. To do this, we need to call the str function to convert a number into a string. Let's execute it and check out what happens. Our number got converted to a string and printed together with the message. Woohoo! We've learned a little bit about variables, values, expressions, and conversions. So far, we've been looking at variables, expressions, and operations, which are the smallest components of scripts. Up next, we're going to look at functions, which are another crucial programming building block. We've come across a few Python functions in our example so far. The print function that writes text on the screen, the type function which tells us the type of a certain value, and the str function which converts a number into a string. All those functions come as a part of the language, and we'll look into a bunch of other built-in Python functions throughout this course. But now, we're going to see how to define our own functions to tell the computer to do things that the language's built-in functions don't. Let's start with a simple example. In this piece of code, we're defining a function. Our function takes a parameter. Here, that parameter is name, and prints a greeting for that name. This snippet is small, but it already shows a lot of important points about how we define functions in Python. Let's go through this step by step. To define a function, we use the def keyword. The name of the function is what comes after the keyword. In this example, the function's name is greeting. So to call the function later in the script, we'll use the word greeting. After the name, we have the parameters of the function, which are written between parentheses. In this example, we only have one parameter, name, followed by a colon at the end of the line. After the colon, we have the body of the function. That's where we state what we want our function to do. Note how the body is indented to the right. This is a key characteristic of Python, and we'll come across it a bunch. For now, just keep in mind that the body of the function must be to the right of the definition. In this example, the body contains just one line that calls the print function. Looks simple, right? But creating functions can actually be super powerful. The body of a function can have as many lines as we want it to, and do all sorts of fun stuff. We'll find out exactly what in later videos. But for now, let's execute our function and see what happens. That's nice, but it's not too interesting yet. Let's make it do a little more. Our function now receives 2 parameters instead of 1, name and department, and it writes 2 separate messages. Again, notice the indentation. We can add as many lines as we'd like to the body of the function, but each line must be indented the same number of spaces to the right. In this example, we're using 4 spaces. We could use 2 or 8 or any other number as long as they're all consistent. Let's try calling our new and improved greeting function. Nice. That's more useful. And we're only just scratching the surface of what we can do with functions. Remember that these are just simple examples, but a function can do a lot more than just print messages. In this course, and throughout the upcoming courses, we'll explore a bunch of other tasks that we can do with Python, and usually we'll write them inside functions. How are you feeling so far? These new concepts are coming fast and furious now. Are you starting to get to grips with it all? If so, awesome. And if some things are still a little fuzzy, now is a great moment to go back and review everything we've covered up till now. Once you're feeling good, meet me on over in the next video. We've seen how we can pass values into a function as parameters by passing values like the name or department in the example earlier. But what about getting values out of a function? This is where the concept of return values comes to play. The work that functions do can produce new results. Sure, we can print the results on the screen, but what if we wanted to use those results later in our script, or didn't want to print them at all? We can do this by returning values from the functions we define ourselves. Let's go back to calculating the area of a triangle. Do you remember our triangle example from our earlier exercise? The area of the triangle is calculated as base times height divided by 2. Imagine we need to calculate this value several times in our code. It would be useful to have a function that does this for us. Check out how this would look. We use the keyword return to tell Python that this is the return value of a function. When we call the function, we store that value in a variable. Let's say we have the 2 triangles and we want to add up the sum of both areas. Here's what we would do. First, we calculate the 2 areas separately. Then, we add the sum of both areas together. Finally, we print the result, converting it to a string. As you can see in this example, the area triangle function returns a value, which is, not surprisingly, the area of the triangle. We store that value in a different variable for each call to the function. In this case, area A and area B. And then we operate with those values, adding them into the variable called sum and only printing this final result. This shows the power of the return statement. It allows us to combine calls to functions into more complex operations, which makes your code more reusable. Return statements in Python are even more interesting because we can use them to return more than one value. Let's say you have a duration of time in seconds, and you want to convert that to the equivalent number of hours, minutes, and seconds. Here's how to do that in Python. Did you spot the new operator in this function? That double slash operator is called floor division. A floor division divides a number and takes the integer part of the division as the result. For example, 5//2 is 2 instead of 2.5. In our example, the first operation is calculating how many hours are in a given amount of seconds, while the second works out how many minutes are left once we subtract the hours, and then how many seconds remain after subtracting the minutes. We end up with 3 numbers as our result, so the function returns all 3 of them. Let's see what this looks like when we're calling a function. Because we know that the function returns 3 values, we assign the result of the function to 3 different variables. There's one last thing we should call out about returning values. It is possible to return nothing, and that's perfectly okay. Let's look at an example from an earlier video. Here, the function just printed a message and didn't return anything. What do you think would happen if we try to assign the value of this function to a variable? Let's try it out and see. Here, when we called the function, it printed a message, just like we expected. We stored the return value in the result variable, but there was no return statement in the function, so the value of result is none. None is a very special data type in Python, used to indicate that things are empty, or that they return nothing. Wow, that was a lot to learn about functions and the return values. Remember that the key to getting this right is to practice writing the code you just learned as many times as you need. Functions and return values can be tricky concepts to master, but they let us do a bunch of cool stuff. So put the time and effort in to learn it for some really valuable returns. As we've called out before, functions are powerful because you can create your own. You can use them to organize the code in your scripts into logical blocks, which makes the code you write easier to use and reuse. Check out this example. This script uses the len function, which returns the length of a string. In this example, the script then uses that length to calculate a number, which we're calling the lucky number here. And finally, it prints a message with the name and the number. Each time we want to perform the calculation, we change the values of the variables and write the formula, then print a greeting followed by the lucky number. See how there are exactly 2 lines that are the same in the first and second part of the code? When you find code duplication in your scripts, it's a good idea to check if you can clean things up a bit by using a function. How about we rewrite this code, creating a function to group all the duplicated code into just 1 line? The updated script gives us the exact same result as the original one, but it looks a lot cleaner. First, we've defined a function called luckyNumber, which carries out our calculation and prints it for us. Then we call the function twice, once with each name. Since we've grouped the calculation and print statements into a function, our code is not only easier to read, but it's also now reusable. We can execute the code inside the luckyNumber function as many times as we need it by just calling it with a different name. So we don't have to write it out and again for each new name. Does that make sense? Hopefully these examples have helped explain how functions are used and defined, and also demonstrated how useful they can be. Did you notice that we're feeding information into our functions through their parameters? This is one of the many ways that we can input data into our code. The values for those parameters may come from different places, like a file on our computer or through a form on a website, but that doesn't impact our code. The result of the function is still the same no matter where the parameters come from. Functions are your friends. They can help clean up your code and do math so you don't have to. You'll be using them a lot, both in this course and in your programming life. So get ready to get real friendly with functions. So far, we've looked into how the Python syntax is used for variables, expressions, and defining and using functions. There's a lot more syntax to come, but before we dive into that, let's talk a bit about a different side of programming: style. On the whole, having good or bad style when you write code doesn't make much difference between a script succeeding or crashing, but it can make a big difference for the people who use it and contribute to it. Poor programming style can make life difficult for the IT specialists or system administrators who have to read the script after it's written or make changes to it so it works with a new system. Bad style can even give the script's author a headache if it's been a while since they've wrote it. Imagine having to rewrite your own code because it's too messy to understand. Yikes! On the flip side, good style can make a script look almost like natural human language. It can make the script's intent and construction immediately clear to the reader. Good style makes life easier for people who have to maintain the code and helps them understand what it does and how it does it. It can also reduce errors, since it makes updating the code easier and more straightforward. And most importantly, good style makes you look cool, right? So, we agree, our code should be stylish. But what makes the style of a piece of code good or bad? Although there are no hard and fast rules that apply to every programming language and situation, keeping a few principles in mind will go a long way to creating good, well-styled code. First off, you want your code to be as self-documenting as possible. Self-documenting code is written in a way that's readable and doesn't conceal its intent. This principle can be applied to all aspects of writing code, from picking your variable names to writing clear, concise expressions. Take this code snippet, for example. It's hard to determine the purpose of this code by just looking at it. The names of the variables don't give the reader much information, and although you can likely work out the result of the calculation, there are no clues to what that result might be used for. In programming lingo, when we rewrite code to be more self-documenting, we call this process refactoring. So how would it look if we refactored this code? With this refactored code, the intent should now be more clear. The names of the variables and the function reflect their purpose, which helps the reader understand the code more quickly. You should always aim for your code to be self-documenting. But even then, sometimes you may need to use a particularly tricky bit of code in your script. When good naming and clean organization can't make the code clear, you can add a bit of explanatory text to the code. You do this by adding what we call a comment. In Python, comments are indicated by the hash character. When your computer sees a hash character, it understands that it should ignore everything that comes after that character on that line. Check out how this looks. Using comments lets you explain why a function does something a certain way. It also allows you to leave notes to your future self or other programmers to remind you of what needs to be improved and why. Obviously, it's much easier to read your own code than someone else's, but in my job, I work on code that was written by lots of different people, and everybody designs things a little differently. This is why it's so important to comment and document your code well. More often than not, your code will eventually be used by someone other than you. So be a good neighbor. Use a style guide to structure your code in a way that's readable by others, or by you in 6 months when you've forgotten why you wrote that code in the first place. In upcoming exercises in this course, we'll use comments to let you know what you need to do with the code, and you can always write as many extra comments as you need. We've seen a few arithmetic expressions so far, like addition, subtraction, and division. Remember when we turned Python into a calculator? Well, Python can also compare values. This lets us check whether something is smaller than, equal to, or bigger than something else. This allows us to take the result of our expressions and use them to make decisions. Check out these 3 examples. In the first example, 10 is greater than 1, so the value true is printed as a result. True is a value that belongs to another data type called a Boolean. Booleans represent one of 2 possible states, either true or false. Every time you compare things in Python, the result is a Boolean of the appropriate value. In the second example, we can see our very first equality operator, which is formed by putting 2 equal signs together. We use this operator to test whether 2 things are equal to each other. In this example, the string cat is not equal to the string dog, so the Boolean that's printed is false. In our third example, we're doing the opposite comparison. By pairing an exclamation mark and an equals sign, we're using the not equals operator, which is the negated form of the equality operator. In this particular line of code, the operator checks that 1 isn't equal to 2. We called out before that the plus operator doesn't work between integers and strings. What do you think will happen if we try to compare an integer and a string? Let's find out by seeing if the number 1 is smaller than the string 1. Womp womp womp. We get a type error. That's the same error we got before. This happens because Python doesn't know how to check if a number is smaller than a string. And what about the equality operator? In this case, the interpreter has no problem telling us that the integer 1 and the string 1 aren't the same. So what gives? Basically, although they may seem similar to us because they both contain the same number, it's clear to the computer that one is a number and the other is a string. For the computer, it's obvious that they are completely different entities. On top of the comparison and equality operators, Python also has a set of logical operators. These operators allow you to connect multiple statements together and perform more complex comparisons. In Python, the logical operators are the words and, or, and not. Let's look at some examples. To evaluate as true, the AND operator would need both expressions to be true at the same time. Here we're comparing strings, and the bigger and smaller operators refer to alphabetical order. Yellow comes after cyan, but brown doesn't come after magenta. So this means that the first statement is true, but the second one isn't, which makes the result of the whole expression false. If we use the OR operator instead, the expression will be true if either of the expressions are true, and false only when both expressions are false. Let's try it out. 25 is definitely not bigger than 50, but 1 is different than 2. So in the end, the whole expression is true. Last up, the NOT operator inverts the value of the expression that's in front of it. If the expression is true, it becomes false. If it's false, it becomes true, just like this. Logical operators are important because they help us write more complex expressions. We'll see this in action in the next few videos. If this is the first time you've come across these operators, it might seem like there's a lot to remember. But don't worry, you'll learn most of them very quickly just by practicing. And in the next reading, we have a cheat sheet that lists all the operators available and what each one does. It's a handy resource you're sure to find useful when writing your own scripts. Now that we're armed with knowledge of Python's expressions, comparators, and variables, we can dive right into how to use them in our scripts to perform different actions based on their values. The ability of a program to alter its execution sequence is called branching, and it's a key component in making your scripts useful. You probably use the idea of branching a bunch in your everyday life. For example, if it's before noon, you might greet someone by saying good morning instead of good afternoon or good evening. If it's raining outside, you might choose to take an umbrella. If it's cold, you probably wear a jacket. In your scripts, you can instruct your computer to make decisions based on inputs too. Let's take a look at an IT-focused example. In many companies, new employees can choose the username they'll use to access the company's systems, and usually the chosen username needs to fit with a given set of guidelines. Companies can set different criteria for what a valid username looks like. For now, let's assume that at your company, a valid username has to have at least 3 characters. You've been tasked with writing a program that will tell the user if their choice is valid or not. To do that, you could write a function like this. This function checks whether the length of the username is smaller than 3. If it is, the function prints a message saying that the username is invalid. Look closely at how the if statement is written. We write the keyword if followed by the condition that we want to check for, and then followed by a colon. After that comes the body of the if block, which is indented further to the right. You may notice that there are some similarities between how an if block and a function are defined. The keyword, either def or if, indicates the start of a special block. At the end of the first line, we use a colon, and then the body of the function or the if block is indented to the right. But there's also an important difference between how an if block and a function are defined. The body of the if block will only execute when the condition evaluates to true. Otherwise, it's skipped. Of course, you can do a lot more things inside the body of the if block than just printing stuff. As we expand our programming abilities, we'll learn how to do things like shorten text that's too long, delete a file if it exists, start a service if it's not running, and a bunch more. If your code is inside a function, you could also choose to return a value depending on whether a certain condition is met. Can you imagine how that would look? By now, you know how to define functions, and inside those functions, you can now make your program do something only when certain conditions are met. The if statement is already a pretty useful construct, but we can extend it to make it even more powerful. Think about the username example from the last video. What if we also wanted to print a message when the username was valid? Here, we've included an else statement to achieve this. The program can now go in one of two directions depending on the length of the username. If it's not long enough, we get a message indicating that the username is invalid. But if the program verifies that the username is long enough, it will print a message saying it is valid. Pay attention to how the else statement is written. It uses the else keyword followed by a colon to indicate the beginning of the else block. Once again, the body of the block is further indented to the right. As we've called out before, these blocks can contain multiple lines and do more than just print messages. They can do calculations, modify values, return values, and a lot more. And remember that you can choose to use as many or as few spaces as you want for the indentation. But you always need to indent, and you always need to use the same number of spaces. The else statement is very useful, but we don't always need it. Say we want to have a function that checks if a value is even or odd. We could do that with a piece of code like this. Here we're using a new operator, so let's first explain that. The modulo operator is represented by the percentage sign and returns the remainder of the integer division between two numbers. The integer division is an operation between integers that yields two results, which are both integers, the quotient and the remainder. So if we do an integer division between 5 and 2, the quotient is 2 and the remainder is 1. If we do an integer division between 11 and 3, the quotient is 3 and the remainder is 2. Even numbers are all multiples of 2, which means the remainder of the integer division between an even number and 2 is always going to be 0. In this function, we're using this principle to decide whether a number is even or not. So, how come we have these two return statements, one below the other, without an else statement? The trick is that when a return statement is executed, the function exits, so that the code that follows doesn't get executed. This means that if the number is even, the computer will reach the return true statement and exit the function. Anything that comes after that will only be executed if the condition in the if statement was false. In other words, once the function reaches the return false line, we know for sure that the if condition was false, which means the number was odd. At first, you might feel more comfortable including the else statement even if it's not needed, and that's totally okay. It's important to know that both ways of writing this are correct. And remember that this technique can only be used when you're returning a value inside the if statement. To recap, the if statement allows us to branch the execution based on a specific condition being true. The else statement lets us set a piece of code to run only when the condition of the if statement was false. If you return a value inside an if block, then the code after the block will only be executed if the condition was false. All makes sense? If all these ifs and elses are starting to get a little confusing, that's okay. There's a lot to soak up here, and the best way to do that is, yeah, you guessed it, practice. So review the content and practice on your own as much as you need. The if and else blocks allow us to branch execution depending on whether a condition is true or false. But what if there are more conditions to take into account? This is where the elif statement, which is short for else if, comes into play. But before we jump into how to use it, let's take a look at why we need it in the first place. Let's go back to our trusty username validation example. Now, what if your company also had a rule that usernames longer than 15 characters aren't allowed? How could we let the user know if their chosen username was too long? We could do it like this. In this case, we're adding an extra if block inside the else block. This works, but the way the code is nested makes it kind of hard to read. To avoid unnecessary nesting and make the code clearer, Python gives us the elif keyword, which lets us handle more than 2 comparison cases. Take a look. The elif statement looks very similar to the if statement. It's followed by a condition and a colon, and a block of code indented to the right that forms the body. The condition must be true for the body of the elif block to be executed. The main difference between elif and if statements is we can only write an elif block as a companion to an if block. That's because the condition of the elif statement will only be checked if the condition of the if statement wasn't true. So in this example, the program first checks whether the username is less than 3 characters long and prints a message if that's the case. If the username has at least 3 characters, the program then checks if it's longer than 15 characters. If it is, we get a message to tell us that. Finally, if none of the above conditions were met, the program prints a message indicating that the username is valid. There's no limit to how many conditions we can add, and it's easy to include new ones. For example, say the company decided that the username shouldn't include numbers. We could easily add an extra elif condition to check for this. Cool, right? You now know how to compare things and use those comparisons for your if, elif, and else statements, and you're using all of them inside functions. Using branching to determine your program's flow opens up a whole new realm of possibilities in your scripts. You can use comparisons to pick between executing different pieces of code, which makes your script pretty flexible. Branching also helps you do all kinds of practical things, like only backing up files with a certain extension, or only allowing login access to a server during certain times of the day. Anytime your program needs to make a decision, you can specify its behavior with a branching statement. Are you starting to notice tasks in your day-to-day that could be made more efficient with scripting? There's so many possibilities, and we're only just getting started with all the cool stuff programming can help you do.
Congratulations on finishing this lesson in the Google IT Automation with Python certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.